Hi there once again and welcome to another Expresso mechanic tutorial, and in this one we're going to be developing this, which is an inflatable balloon simulation. In order to achieve this we're going to be using a combination of Expresso, Python, Dynamics, a pose morph tag and finally a point cache tag to make it all hang together. So without further ado, let's see if we can make this happen. I'm going to build this one for you from scratch. So we're going to start with a cylinder. And I'm going to work at actual size here. So I'm going to take this down to a radius of 2.8 and a height of 10 to start with, one height segment. The rotation segments, well, we can leave that as 16 actually. It'll be fine because I'll be dropping it into a subdivision surface a little bit later. We'll make it editable and hit O on the keyboard and bring it close to us. So where are we going to begin? Okay, let's just go into our polygon mode here. First thing I'm going to do, I'm just going to go KL for knife selection. I'm just going to put a cut somewhere around there, and UL for loop selection. Grab a hold of all of these and just bring them up just to about there. I mean, you can do this by eye, it's not that important, but that will do nicely for that. And then I'm going to simply say D for extrude and probably about 0.5. Yeah, well, we can go 0.75. 0.75, yeah, that's fine. 0.75 is good. And then I'll just bring this in very, very slightly with the scale tool, just to give it a little bit of a bevel on there. Again, by eye is fine for all of this stuff. Just get a little bit closer to it. And then I'll say I for extrude inner and try 0.5. It's probably going to be too much. 0.2, yeah, 0.2 is fine. And then again, D for extrude, and this time it'll be minus 0.75. And that just about sets that up for us fine. Let's have a look, see where we are. Yeah, all looking quite good. One thing I may do though is just go into my top view. So function 2. Again, hold down control and just zoom in to here. Select my live selection tool, or my rectangle selection tool I should say. Select all of these and I'm just going to make it slightly wider. So I don't need to do it in the Y, so I'll just switch that off. Just make that slightly bigger. That should be okay for us, I think. That should do nicely. Great, so that's the first little bit of the air cylinder developed there. Let's just go underneath here and UL to select all of these. I for inner extrude, and I'll go 0.5, which is too much. Try 0.2 on there then. In fact, I think that could be 0.1. Doesn't really need to be more than 1 millimeter in thickness to all of that. That's fine. And then D for extrude, and I'm going to go minus 9, and we'll just take a look in our side views. You can go a little bit further, so let's say minus 10. Thinking about it, no, minus 10 is too far. I'll go minus 9.8. That'll do nicely. That way we won't get any bleed through or anything like that, which is good. Okay, so that's the first bit of our cylinder developed. The second part, we just need another cylinder, and this one I'm just going to leave as it is. I'm not going to make this editable, so I'm going to call this the plunger, and I'm going to call this one just air cylinder. The plunger, we can take this down to a radius of 2.7 so that it fits inside the air cylinder, and a height of 9. Go into our side view again and we can see what we're doing, and if we drop this down we can see that it's working. It's fitting between the walls of the air cylinder. So that's great. The next thing I want to do is bring in a null object. In fact, I'm going to group, I'm going to select both of these and group them into a null. I'll just say Command G to group them, or Alt G I should say, to group those two into a null. And I'll just call this pump. So my plunger is, or needs to be, I should say, set at 0. So my null I need to bring down to where the actual plunger is. So what I'm going to do, take these two out of there, and then group the pump into the plunger, 0 it out, and then place it back up the top and group them back into it. So my plunger is now at 0 and I want it to move to just about 7.5. Let's have a look where we are. 7.5 might be a little too far. So if we said 7, yeah, I think 7 is fine because it's just about reaching the sort of the maximum limit there, I think. So let's just change the colour of it. Just make it yellow so we can see it more easily. Yeah, I mean that'll do nicely. That's okay for that. So that's the first bit of the pump done. Now, just to finish it off, what I did, first of all, I dropped it into a subdivision surface, the air cylinder, just to make it slightly more rounded. And then I won't do any work in the subdivision surface. I'm just simply going to select the cylinder, hold down my shift key and add a bevel, and then do some work in the bevel. The offset I'll make 0.1 and I'll give it 3 subdivisions. And that's great. You can see it's tidied everything up and it looks really quite smart now. It's given us a nice result. I'm going to leave that like that. So that's the air cylinder pretty much complete and ready to go. Our next port of call is to create the balloon, and to do that we start with a sphere. At the moment it's massive, so we need to give it a radius of 2.5. Segments will say 20, and the standard type is what we need for our purposes here. So we'll just bring this up. I'll go into a side view actually so that we can see where we are. Bring it up just to say here for a starting position, that'll be fine. Hit O to just zoom in our 3D view, and I'm going to switch the display to Garage Shading Lines and also go into Isopalms. The sphere I'm going to make editable and then select Polygon Mode and UL for loop selection, and I'm just going to take away these bottom polygons there because I want the bottom of it open. Switch to Edge Mode, UL again, and then we can start working with our edges. Let's just go into a side view again, and I'm going to drop these down to somewhere there. I'll move the whole balloon actually, but in fact I'll take these down and then zoom in a little bit and then get them within the nozzle of the air cylinder. I'm just going to scale those in so that they're within that nozzle. That looks good. I can drop them down a little bit further, and then I can work with the edges here as well and just bring these down to somewhere probably around there should be good, I would think. And then what I'll do is, again, I'm just going to do it by eye. I'll bring these in generally until they match up with the bottom edges so that we get something like that. That should be okay. Yeah, that's good enough. I think that's fine. And then one more set of edges. I'll just select this edge loop here, drop these down just somewhere around there, and then scale those into somewhere just about there. Let's just zoom in and see, or zoom out I should say, and see what we can see. So we're getting something that's sort of resembling a balloon, aren't we? It's not 100% perfect yet because we need to drop it into a subdivision surface. So we'll do that now. Hold down the Alt key and hit a subdivision surface. And now you can see that we're getting something that does in fact resemble a balloon that's just got a little bit of air in it. That's what I'm looking for a starting point. A balloon that's just got a tiny amount of air in it, so it looks like a little bulb. That's the kind of thing that we're looking for to start with. And we can see that the scale of that, it's pretty good. I would say that that's okay. That seems perfectly acceptable to me. But yeah, I'm liking that. I'm liking what we're seeing there. So that's our starting point for our balloon. Before we continue, it is worth noting that if you want to do anything with texturing involving Body Paint 3D, which is what I use to do my balloon texture, then now is the time to do it before you move on to making this thing animated and dynamic and all the rest of it. So yeah, don't wait until you've done all that animation and then decide you want to go into Body Paint and do it. I actually managed to crash Cinema 4D by doing that, so it's something that you need to bear in mind. Anyway, let's move on and take a look at the next step. With my sphere selected, I'm going to select tags, come down to rigging tags, and then add a pose morph tag to my sphere. I'm going to say we need to be in points mode. That's what we're going to be working with. So we'll put our sphere in points mode and go into a side view. Now these points that are selected are fine. What I'll do is just move them up to around, say, this line on this grid line here. That would be fine. And then I'm just simply going to scale them firstly along the XZ axes, and then I'll also scale along the Y axis so that we get a better idea of what we're seeing with regard to what our balloon looks like. Just bring those out slightly and perhaps up a little more, say to around there. I think is a good shape for a balloon. Just make doubly sure that it isn't overlapping the edges. No, that's fine. That's looking great. That's looking perfectly good. Yeah, I mean that's looking good, isn't it? I mean, I think that will do nicely for our final pose for our balloon. So let's just go into our pose morph tag here. We're in edit mode. If we just go into animate and let's see what we get. So yeah, that's working beautifully. So that's the next little part of this to actually get it to animate. We'll just take that pose back to 0 there, the pose strength, because we need to work with the balloon in its initial state for our next step, and that involves adding the dynamics. The balloon itself won't actually be a dynamic object. We're going to be using a mesh deformer in order to make the balloon behave dynamically. So it will actually be controlled by what's going to start life as a cube, and we're going to make this into a cage that we can use to deform the balloon. It's a little bit too big at the moment, so in its x-axis we're going to make it 6, we'll make it 9 in the y and 6 in the z. That'll give us a starting point. In the segments we'll make it 3 by 6 by 3. Just move it into position or somewhere near where we think it should go. Switch to a side view and let's just check and see what we've got. Well, that should work. I'm happy with that. I think that's going to do what we need it to do. So we can make our cube editable by hitting C and then switch to a top view and start manipulating this into the shape that it needs to be. I'll just select the corners, and because I don't have only select visible elements checked in the options tab, we're selecting everything along the edges of our cube there. So in our top view we can switch to our scale tool and just bring these edges in so that we get something a little bit more circular, and that's given us a great starting point. Let's have a look again in our top view. This time I will actually select or check only select visible elements, and I just want these 4 points. And again, I'm just manipulating this gradually. I'm just going to move those up a little bit. UL to select these and then bring them down to somewhere around there. And then if I can, don't know whether this will work. It may. No, it doesn't. It's a little bit finicky, I find, that the loop selection tool. What I'll do is simply use rectangular selection. It might be easier actually. So let's just bring this down to around there. And what I'll do with the second row here is just bring those in so that we get a more rounded effect there. And then I'll just manipulate these in as well so that they're about like that. That should be fine for that. Next row in, I'm going to bring this in just slightly too. And then I'll skip this particular row because I think that's okay. Bring this one in to somewhere around, say there. Bring these in again to somewhere around the same distance away from the balloon, and then finally I'm going to select both of the bottom rows here and bring those in until they're just proud of the nozzle of the air cylinder there, just to about there. That should work very well. In fact, that top, that second row down from the top, I'm just going to just bring those in just a tad more so that it's just there. Yeah, I mean, that looks good. That looks good for the cage. So that's the next part of this done. Moving on from here, we'll add a mesh deformer to the sphere. So I'll just hold down my shift key, come into my deformers, select mesh, and that's given us that. And then in the cages we can drop the cube into there. And we're okay with that, so we can say auto init, we'll put that on and we'll initialize, and our cage has now been set up and we're ready to make it dynamic. The first step to achieving what we want to do is to actually select the cube, come into our selection menu, and we can just say set vertex weight, because we do need to give this a vertex map. The value is fine at 0% and the mode being set is great, so let's just hit OK. And we've got a vertex map in there. I'm going to hit Shift and C and type the word paint so that I can get my paint tool, and it's now selected, and we can see that our vertex map is now illuminated and all our points are currently set to red. So I'm just going to hit O to zoom a little closer so that we can see what we're doing. The bottom two rows, or bottom two loops I should say, of points can stay at 0. They're perfectly good. In my paint tool though, I'm going to come into painting here, just select the painting tab. It's set to absolute mode, which is great for what we're doing. Now the opacity I don't want at 100% at the moment, I want it at 50, and that's for this second row here. I'm going to make these 50. Now I want not to select visible only, so I'm going to just uncheck that because I want to go through to the back points as well. So I'm just going to wash over those and select those points, and they're now set to 50%. I can then set the opacity to 75% and do the next row. So I've got that. Those points are all selected. Set the opacity to 100% and it will be the next two. So I'm going to switch to a side view and I'm going to do these in here. So these are going to both be 100%. And then I'll go back to 75, do the next row, and then the top row 50. And I've found that this setup actually works very, very nicely. Bit of experimentation to get here, but that's what I've found works. So that completes our map, and we're going to be using this in our soft body dynamics, which we're going to be applying to this cage, and that's the next step. The first thing I'm going to do is hit Command and D, and we'll take a look at our dynamics. Now, at the moment, the collision margin and the scale are much too large because we're working at a very small scale here. So the collision margin, I'm going to make it 0.1, and I'm going to make the scale 10. I'll leave the steps per frame at the moment, but we'll come back to those a bit later because I'm pretty sure we're going to need to make an adjustment there, but we'll leave it for now and see what happens. Moving on from here, I'll select my subdivision surface. In fact, I'm going to rename that air cylinder, and I'll just take away the name from there and just leave it as a polygon. And moving on from here, I'll select the air cylinder, my tags menu, and come down to simulation and give this a collider body. Now I'll just go into my collider body, and in my dynamics the setup can be left as it is. That's absolutely fine. No need to change anything in there. The collision though, we need apply to children. That can be left on, and we can leave the individual elements on. That's fine because we do have children. The static mesh is absolutely fine, and we will switch on the margin. We'll just leave that as it is. The bounce and the friction, I'm going to leave those alone for now and make any adjustments that I may need to at a later point. Moving on from here, I'll select my cube, tags, and come down to simulation and give this a soft body tag. In here, we don't need to apply to children because there are none, so we'll say none and switch that off. As shape, I'm going to select moving mesh, and I will use a collision margin and just leave that at 0. Again, I'll leave the friction and the bounce for now, and we'll play around with those a little bit later. In our soft body tab, the thing to do now is to get a hold of our vertex map here and place it in the mass map. That's what we're going to be using this for. The only adjustment I'm going to make to anything here at the moment is with the flexion. I'm going to make the damping 50% and leave it at that. Everything else can stay the same at the moment. Okay, that's the basic setup for our dynamics complete. Now let's just see what happens here when we play the timeline. So it falls straight down. Is it doing what we want it to do? Not really. So let's just stop it. Just hit H so that we can see everything. And let's start doing a little bit of adjustment here and there. So in the collision, we've got bounce of friction. I'm going to make that slightly lower. Let's make it 50%. And in our air cylinder here, self collisions we don't really need, so we switch those off. Margin, as I say, we're going to leave. Keep soft body shape, we don't need to worry about that, and we don't need to worry about much else. Deformed object, we'll leave that in there because we are using a deformer on the object, so we'll leave that in there. Now the friction, let's just turn that down. Let's try 50% in there and get this bounce down to about 10% and see if that makes any difference to us. Let's just see what we're getting now. So it's trying to slip over the edge. Is it going to fall over? And it does. So we've got an interesting shape. It's not correct, but it's interesting. Now one of the things I want to show you here, if we go in closer, this is not in the right place. It's clearly moved. And you can see that these points have moved, and they've also twisted. I don't know whether we can see that in a... Yeah, you can see it in that particular view. If we just go to H and just see everything in there. No, it's not the best view, so let's go back to our other view. Now you can see that these points, they're at an angle. The ones that I actually said I didn't want any influence on, the ones that I set to 0 in the vertex map, they've still moved. Now they should be rooted to the spot. So why have they moved? If we go back to 0 here, now why have they moved? Well, if we go into our cube, in fact it's still in our dynamics actually, so if we go into our forces, we've got the linear damping and the angular damping, and they're both at 5% and they need to be zeroed out. So let's zero those. And if we run that again, we're still going to get the same result initially, and then it should fall over the edge. And now you can see that they're still in the correct place. So that's solved that particular problem. We've still got a few other issues that we need to deal with, but it solved that particular one. So let's just go back to 0. Now part of the problem, I think, is that this second row of points are too low. They need to be raised a little bit higher. So let's do some work there. The way to deal with this, if we select our mesh deformer, if we remove the cube, we can then start to work in it again. So if we just come down to our only select visible elements and check that off in our selection tool here, we can just select all of the points around the loop there. All of those points are now selected, and we can just move these higher. And we could probably do the same with the second row actually. In fact, I'll use the rectangle tool to make that a little bit quicker, speed the process up a bit, and we'll just move that up, and then I can just rescale those slightly. What we can then do is select our mesh again, put the cube back in and reinitialize that, and let's see if that's made any difference. So if we just run that, it'll flop over. Okay, and you can see that that has solved one problem there. We've now got the balloon that isn't going through the nozzle of the air cylinder there, so that solved that one. So if you get that problem, that's how to solve it. We've still got a bit of an issue with collision with the actual collider body, and we need to sort that one out. The way we correct this is to hit Command D again, and I mentioned earlier that the steps for frame I may need to adjust. So if I put 10 in there and we rewind back to the beginning, and now let's see what happens. Oh, a completely different behavior, and as you can see, well and truly behaving like a real balloon now. Great, looking really nice. Okay, so that's how you set that up. I'm pretty happy, I think, if we just hit H to see the whole thing. Now I'm pretty happy, yeah. I think that looks really good. It's very, very believable, very credible. So that is fine, I think, for a starting point for our balloon. It's behaving exactly as we want it to, and it looks fantastic. So what we can do in our dynamics tag for our cube, we can go back to dynamics and we can say set initial state and then rewind to the beginning. We'll always get that bit of a problem, but don't worry about that. Just another click on the rewind there to the beginning and you'll find that it'll sort itself out. Don't quite know why that does that. I think it's probably to do with the way the dynamics are actually calculated, but the workaround for it is to click this button again and you'll be okay. Anyway, all is good and we can move on from here. I'm going to select my plunger and I'm going to go into the coordinates here, and at the moment it's set to 7. I'm going to set it back to 0 and then hit H so that we can see everything. Now on the first pump of the plunger, so when we do this, we want the balloon to leap back up into its start position and oscillate. That's what we're going to do. So we'll do the plunger first. So let's just get a hold of it here and set this back to 0, and we can set a keyframe on its position Y there. I'll move forward on the timeline to 15 frames, set the position Y of the plunger to 7 and set another keyframe, and then I'll move to frame 25, set the position Y back to 0 and record a third keyframe. So when I run my timeline, just do that double click again, I'm getting that motion. Now as that happens, we need the balloon to move. The way we're going to do that is to come into the dynamics tag here and we'll start work with the soft body. It's perfectly simple to achieve this. We don't need to touch any of this stuff, so we can leave all of this alone. What we do want to do in the shape conservation though is work with the stiffness, and we want to work with the dampening, or the damping I should say. So if I set a keyframe, well, I'm just going to click off that there so that we select none and just select the dynamics tag so that we don't get confused with what's going on in the timeline here. So if I say set a keyframe at 0 for the stiffness and another one for the damping, and then I move through to frame 15 and we set the stiffness to 1000, keyframe that, and the damping we set to 100% and keyframe that. Let's return to 0 and let's see what happens. I'll just adjust my viewport here and we'll see what happens. And straight away we get the result that we want. We can see that the cage has quite literally reformed itself into the initial state that it was in when I first built it. It's exactly as it was before, and that's thanks to our map that we created, our vertex map. That's what's causing that to happen the way it is. It's working beautifully, and we can see that that actually animates in a way that's very, very believable, and that's exactly what we need it to do. So just see that again, and there we go. Beautiful. Fantastic. And that really completes the dynamics of this particular project. We don't need to do any more with that. That's working exactly as we need it to do. Moving on from here, we need to set up an Expresso expression, and we also need to bring Python into play, and that's where we're going next. We'll grab a null and rename it Expresso. Come into our tags, come down to programming tags and select Expresso and get the window open. Now, we know that the plunger, when it's moving in an upward direction, it will be pumping air into the balloon. That's the only way it can work. So when it's going down, it doesn't do anything. We've got to emulate this within our Expresso expression. And the way we're going to do that, we'll bring the plunger in and come down to coordinates, position Y, and we'll also give it a previous position output port. Next node we're going to need will be a logic compare, and we'll set the function to greater than and plumb the position Y into input 1. Moving on from here, we will get an adapter node and it will be a vector to reals. Position this about there, plumb the previous position into the input, which of course is a vector, and we'll convert this vector to a real value, and we're only interested in the Y. So now we're saying if our position, or our current position Y, is greater than our previous position Y, then we get a true output because we know that we're pumping air. That's the point at which we're pumping air. The next node we're going to need will be a monoflop, and we're only going to be using this as a counter. So we'll give it a reset, and we'll also give it a count at the output stage. And we'll plumb our output from our compare into the trigger. And in our mode, we need to set it to a one-shot, because a one-shot monoflop, of course, requires a 1 at the input of the trigger to make it work. So every time our cylinder for our plunger is moving in an upward direction, we're going to get a 1 at the output, we're going to trigger the monoflop, and the count value is going to increase. And we're going to be using this within our Python node a little bit later on. Now when we're back at the beginning of our animation, we will want to reset that counter value. So we'll get a time node. As per usual, I'll remove the time port, just get rid of that port, and I'll add a frame port. I'll command drag to create another compare node, but I'll change the function to equal to, plumb in my frame into the input 1, and from the output I'll just plumb that into the reset. So now when we're at the beginning of our animation, we know that we're going to reset the monoflop. We're also going to be using this a little bit later on, but for now we'll make our window a little bit bigger and reach for our Python node. So we'll come down to Script, Python. The first thing I'm going to do is what I always do and remove all the ports. Just start from a blank slate. I'll add a couple of floats and rename them. The first one I'm going to call Strength, and all will become apparent a little bit later. Call the second one Air, and then I'm going to add a couple of integers. Just make our node a little bit bigger. And this first one I'm going to call Bool, and the second one I'm going to call this Count. And at the output stage I'm going to add a float and call it Inflate. And that's as much as we need to do with the Python node in terms of its inputs and outputs. I'll just get my view back to 100% and we'll start looking at what we're going to plug in where. The strength, I'm going to drag in my pose morph tag for that, and in my tag properties, pose naught strength is what I'm going to be using there. So that can be plumbed into the strength. The air is the position Y. So when that's moving in an upward direction, it's going to be pumping air. The compare is going to be the bool. The monoflop will provide the count, but before we get to that stage, we're going to bring in a math node. And this is going to be a subtract. And in our input 2, I'm going to put 1. So let's bring that back to 100% again. I'm going to plumb my count value into the input 1. Move this over here a little bit. And then plug the output into the count. Now at the moment, we just get a result node. We can see that the actual output is -1. But as soon as I hit the timeline, or if I bring the timeline back to 0 and then I just go a frame forward, instantly it's 0. If I didn't subtract, of course, it would be 1. Now that can present as a problem with what we're doing in here, because we don't want the first pump to be 1. We're going to want it to be 0, and that's why I've put this subtract in there. You'll see a little bit later exactly how this is going to work. So in our Python node, we'll come in here and start doing a bit of work. I'll do it in the editor, so we'll open that. The first thing we can say is from C4D, import utils. I'm doing this because we're going to be using a range mapper, and as you know, if you've done any of my Python tutorials, that's where the range mapper resides. It's in the utils module. We'll remove this line because we don't need it, and we'll set a couple more global variables, and these will be lowers and global uppers. And I'll start defining these. So lowers is equal to, I'm just going to say an empty list for a moment, and I'll do the same with uppers. So they're both empty lists. If we just take a look at our pose morph tag here, it starts from a value of 0% and it reaches 100%, and we can see the balloon is reacting accordingly. Now, that's what we see when we're working with it in keyframes or with keyframes. However, when we're programming, it's a different story. It's actually working with a value between 0 and 1. So with my lowers, I'm going to set 5 values, because what I'm going to do, we're going to actually pump this balloon up with 6 pumps of the plunger. The first we've already defined, and we know that that just brings it to the initial step with the dynamics. The next 5 we're going to use to gradually increase the value of the pose morph. So it's going to go from 0 to 20%, from 20% to 40%, 40 to 60, etc. So we've got to set those values in these 2 lists. So we can start with a value of 0 in our first position in that lowers list there. Then we can say 0.2, 0.4, 0.6, and finally 0.8. And they will be our lower values. In our uppers, we can start with 0.2. In fact, what we'll do, we'll copy all of these, paste them in there, and then simply add a comma and a 1 to finish it off. So you can see 0 to 0.2 is 0 to 20%, etc. That's what we're going to do. So it's gradually going to pump up over 5 pumps. And we're obviously going to use the index values in order to pass these into a range mapper. And that's the next thing we're going to be working on setting up. So let's just start by saying if count is greater than or equal to 1 and count is less than 6. So when we're between a value of 1 and 5, we're going to be moving on and making this work. In fact, it can be less than or equal to 6. It doesn't really make a lot of odds. So that will be a value between 1 and 5. So we'll be ignoring the first pump, which is what I said we needed to do, because that's the one that works with the dynamics. We're not bothered about that in the Python. We just want the 1 to 6. We can then say if bool is equal to 1. So if the plunger is moving upwards and air is being pumped, that's when we're interested in using what's coming next, and that will be the range mapper. So we can say range mapper is equal to c4d.utils dot range map brackets and air. That will be our value, and that's a value, as we know, between 0 and 7. And then we can say lowers square brackets count minus 1, because we know that count is going to be greater than or equal to 1. However, we need it to start from 0, so we must subtract 1 in order to use the first index values. If we left it without that minus 1, we would start from we'd start from 0.2, then between and obviously 0.4 in the uppers. We would skip this first one, and we don't want to do that. So that's why we're doing that. We can then say uppers square brackets count minus 1, same thing, comma, and then true, because we are using positive values, not negative values. Now normally I'd probably put another comma in and put a spline in, but I'm not using a spline, so we don't need to bother with that step. The range mapper will work fine as it is. Moving on from here, that's if the bool is 1. Now if the bool isn't 1, if it's 0, then obviously we don't need to do any of this, but we do need to hold our balloon at its current point of inflation. So we need to hold the balloon in stasis, if you want to put it that way. So we can say else. In fact, I've just got to add one more line before I do that. I've got to put inflate is equal to range mapper in there. Otherwise, we're not going to inflate the balloon. So that just deals with that. And then my else can be inflate is equal to strength. So when the air is being pumped in, we're going to do the range mapper, and at every other time we're just going to be using the pose morph, the current value of the pose morph. So if this was 20%, then that's what we're going to be using in this else. So inflate will be strength. Finally, we just need to put another else in here and say again inflate is equal to strength. So that just holds it in stasis at all other times. Okay, and that's it. That's all you need to do with the Python code. That's as much as you need, and it will look after things perfectly well. Before we close the window, I'm just going to hit the execute button, because as we know, if we don't do that, everything gets lost. So you must always hit that execute button. And then if I select my Python node in here, we can see that the window has updated and everything is okay, and I can shut this down. Moving on from here, I can bring in some more nodes just to get this working. And I said that we were going to use these a little bit later on, and we've come to the point where we are going to use them. So what I'm going to do is grab a hold of a condition node and I place it over here, and the compare is going to operate the switch for this. So when we're at frame 0, we're going to be wanting a 0 at this output here, and at all other times we're going to be using the output of the Python node. And then the final step for this is to bring in the pose morph tag again, come down to tag properties, select pose strength, and plumb that into there like that. If I just expand the window so that we can see everything. Okay, so there's our expression. I'll just disconnect that for a minute. And that's as much as you need to do. So we get our air pumping, we count the number of times that we're doing the pumps, subtract 1 because we know that we want to ignore the first pump because that just works with the dynamics. And then we pass everything into the Python node, and that handles the actual status of the pose morph tag. That's what's being done there. Obviously, when we're at the beginning of the animation, we reset the counter value of the monoflop, and we also make sure that our pose strength is set back to 0. That's as much as we're doing in there. So it's quite a simple expression, although there looks to be quite a lot to it, but that's exactly what we're doing. Now, all things being fair, if I run the timeline, this should work, okay? So what I'm going to do before I do that is set things up. Well, first of all, we'll set 200 frames in the timeline, but we've also got to do a little bit more work with the plunger and the keyframing here. So we'd already set this initial pump up, but we haven't done the remaining 5. In order to do that, we're going to hold down a control key on my Mac here, select animation and come down to F curve or show F curve. Select the position Y, and now we've got the track up here in the attributes manager. We can leave the before at constant, but the after we're going to set to repeat and 5 to give us 5 repeats, to give us our remaining pumps. Okay, now let's see if this actually works. So we'll go back to the beginning and we're ready. I'll just make the window a little bit bigger or zoom out a little bit so that we can see everything. And let's hit play and see what happens. Well, that's not doing what we thought it might do. I wonder why that might be. Well, actually, I know why it is. There's a couple of steps that we haven't done, and they're quite important. They're simple, but quite important. If we select our pose morph tag and we go into the edit mode, in here we've got post deformers and it's unchecked. We are using a deformer, a mesh deformer within the sphere, which is the object that's associated with the pose morph. So we must check this box. That's the first thing. And then we can go back to animate from there. The second thing, if we open our Expresso expression and click on our Python node, we've got reset on frame 0, and that's unchecked as well. So if we check that, hopefully that solved the problem. Let's see if it has. And it still hasn't. So if that hasn't solved the problem, then there's one last thing that we can try. And I sometimes get a problem with monoflops in Expresso, and I do think there's some kind of, I don't know whether it's a bug or whether it's to do with multi-threading. I've said this before, I think, in other tutorials, but if you sometimes plug a result node into, and it could be into the count, or it could be this, I'm plugging it into the subtract here, but I'm hoping that that will help us solve the problem. And it does. That's very, very strange. I don't know why that happens, but bear in mind that you sometimes need to do that with an Expresso expression. You should find when this loops, it starts again and it all works. So that's working pretty well for us, isn't it? And we're getting the effect that we want. However, there is one final stage to this that will give us a lot more control over the art direction, and that's to add a point cache. So that's what we're going to do next. I'll just reset my timeline, select my cube, come down to rigging tags, point cache, and I'll store the state. And in the auto time, I don't actually want that, so I'll uncheck it because I only really need 100 frames. It's not dynamic for 200 frames, so 100 is perfectly good. And then I will calculate the cache. Okay, and that's done. The next thing, I'll just select my dynamics here and come into the cache tab there, and I'll bake them. Just bake the dynamics. Okay, great. So they're stored away, and now I can come into my dynamics tab and check on the enable to disable the dynamics. And now we're working purely with the point cache. I'll also hide the cube so that we get a better idea of what we're doing, and then we can just check and see what's happening. Now it's not working at the moment. There's a bit of a problem, and it's perfectly simple. We must check the transform box. So we'll check that one, and away we go. So that's working beautifully. However, it doesn't stay dynamic for very long. And the beauty of the point cache is that we can actually retime things by using the scale value. So if I set that to 50% and then we run the timeline again, you can see that the balloon is sort of floppier for longer. And it adds weight to the balloon effectively, but I actually like the effect of it. I think that actually looks quite nice, and it just keeps it more dynamic for just that little bit longer, which I think adds something to it. Of course, you can go the other way. So if you wanted it a little faster, just say 120%, reset the timeline and play, and it's faster. So you've got a lot of control over the art direction of the way this thing works simply by using the scale. So that's why I've added the point cache. But anyway, that is just about it for this tutorial. That brings us to the end, and that's the way you go about creating a dynamic inflatable balloon. So I really hope you've enjoyed this tutorial. It's been a lot of fun doing it. There's been a few headaches along the way for me, but there always are. But nonetheless, it's been a lot of fun. So if you have enjoyed the tutorial, please give it a thumbs up. And if you haven't already, then please subscribe to the channel and ring that bell. And of course, wherever you happen to be on social media, please share the video, because all this good stuff helps to keep the channel going in the right direction. But anyway, that about wraps it up for now. So I'll see you very soon on the next tutorial.